last two here. The letter G is sine times cosecant over tangent. Folks, again, my suggestion is get everything in terms of sine and cosine. So sine is already in terms of in terms of sine and cosine. Cosecant is the same as 1 over sine. And then the denominator tangent, I'm going to make that as sine over. Actually, you know what? I'm not going to complicate that one at all. Let's just leave that as tangent for now. I changed my mind midway through. So when we have in our numerator sine times 1 over sine, again, that's using a reciprocal identity. Sine times 1 over sine in the numerator gives us just 1. And so we have 1 over tangent. And folks, 1 over tangent, that's just cotangent. And that is a reciprocal identity as well. So keep it simple. There was a different way that I could have shown you that, and I realized, oh yeah, let's just keep it simple. The last one, letter H, sine times tangent plus cosine. So again, we got sine of theta, and then tangent I'm going to convert into sine over cosine using your quotient identity. And then we'll just leave plus cosine alone. Now, in that first fraction, or that first group, sine times sine over cosine, if we multiply those two fractions out, we got sine squared of theta over cosine plus, and then the other one's just cosine. So we have a fraction plus something else. In other words, let's try to add two fractions together. Now, in order to do that, we got to have a common denominator. So I'm going to multiply this second fraction by cosine over cosine to get a common denominator. So, and that means in the first fraction, we'll still have sine squared, that was messy, sine squared over cosine. And then in the second fraction, after we multiply that out, we'll get cosine squared over cosine. When we add those two fractions together, we got sine squared of theta plus cosine squared of theta over cosine. That numerator, that's hopefully looking kind of familiar to you by now. Let me actually shift this over just a little bit. That numerator, sine squared plus cosine squared, looking over here on the left side, that's just equal to 1. So we end up with 1 over cosine. That's a Pythagorean identity. And 1 over cosine is the same as secant of theta. I just realized I'm off screen again. But let me shift that over. That's secant of theta, and that's just a reciprocal identity. So that original polynomial, or that original statement of sine times tangent plus cosine simplifies all the way down to just secant.